we can count number of nodes online in an efficient manner. It costs me just a handful of bytes per minute, so I can count any slice network, I can count the entire galaxy, no problem. A number of unique nodes per month, or per week, or per day, or whatever. But this one I'm particularly proud of, because no one else in the world has solved that yet. I'm still, as far as I know, the only one guy in the world who knows to do that. I can take network statistics like average value, median value, max, minimum, and it seems I can do percentages, percentiles. But sorry?
Yeah,
percentiles, yeah. But back when I did it, my percentiles weren't right, so I probably need a little bit more work to solve it. And I'll actually show you how to do these things, because they are kind of simple ideas. I can do totals, for instance, number of files shared in the entire network. So I can get, that's actually fairly useful. I'll take the median value for all of nodes, how many files they share, and then I know number of nodes online and just multiply those two values. That's actually how I do it, so it's just based on two of the other ones. And the network, we can agree about network time, so we don't need any clock server. All the nodes can just agree about what the clock is now. Even if many of the clocks are going really, really wrong, we can still agree about them. I actually do the median value. I just all nodes publish for their clock, and I take the median value of that. And then everyone gets the same median value, or median value.
So what sort of accuracy are you talking about for like number of nodes online, unique?
I can do it as actually as you want, but what I'm using, let's see. I send one message a minute initially, and that message is, I think, is it 64 bytes, I think. Contains 33 small values. I'll explain how that works tomorrow or today. And so it's like less than 100 bytes a minute of traffic, and I get within 2% of the true value. Well, in 99.9999 of the cases.
Okay.
Percent of the cases. So I can do it very, very exactly. I'll teach you that algorithm. It's really fun because it's randomized, extremely randomized. It uses randomness in a way that people don't even think is possible. Most of the nodes don't broadcast anything, they just think. If they forget to think, they won't be counted. But they don't communicate anything, so it's really weird, but it's simple. We will look at but there's some bad things with it. Most of these values can be cheated. An evil node can lie and get the values wrong. For instance, my count the number of nodes online, we can't lower the value, but an evil node can increase the value. So if there are actually 1 million nodes, it can make it 2 million nodes or more. But it can't make it less at least. So this one is in that way robust in one direction.
Except that comes back to the symbol attack.
Yeah, that's it. You insert a couple of nodes and they start broadcasting the false data. And so all of these are really, well, those two you can increase. These ones you can, well, the max and minus, of course, is simple. You just say something lower or higher, and then you win. The averages, you can, if you are many nodes, you start moving the average away. But you have to be many nodes then. Because we want to, of course, we have to have some intelligence. If a node says a value that obviously can't be true, then throw it away. But that means that they can push it up or down. But the median value actually is fairly stable, because we pick actually the value from the median node. So if you have nodes saying something else, it will just disappear in the one end. So the median value will just move a little to another node, and then that's usually the same value. So the median value is very stable.
Could you use something else to corroborate that information?
Yeah, there are several. I'll show you several numbers for something else. Because, for instance, there are 3 ways to do that one, in known ways.
Yeah.
And I'll show you them. I'll do that later today or tomorrow. So we'll go through all 3 of them, and I'll just tell you why I think my method is the best one.
Right. So the one thing there that a malicious attack would really cause problems would be network time.
Sorry?
So the having a dependable network time is probably the most useful.
Independent
things, I think.
Yeah, because my methods are broadcasting based, and you can broadcast on any structure. So
I mean, if someone successfully messed with network time, that would probably cause more problems than like the number of nodes for most things, I think.
Yeah. Well, You can't trust any one of these. There's no way to do this in a secure manner.
Yeah.
No, it is impossible as far as I know.
Mhm.
But network time is fairly stable because I base it on the medium
Right.
value.
Right.
So it's hard to make it very wrong, but you can make it very wrong if you have enough
Yeah.
resources. So never, I will say that in computer security, never trust time. Never. You don't do that. You don't need time for everything.
Yeah.
There's a lot of ways to handle.
Well, as long as it goes in one direction.
Yeah, but you can't even trust that.
Mhm.
Yeah.
So never trust time in a security system because we don't need it. All our values I've seen that are built on time. We already have better values that are not built on time.
Mhm.
So whenever you see time as a part of a security scheme, then you know they're competent and then you understand. So I'm sorry.
So, just to back up, what is the utility of these different metrics? Like, what sort of things
These
are
are
they?
for viewing pleasure.
Okay.
So you can have click and see number of nodes online, statistics about the network. What the guy building it, he wants to know, of course, how much people are using it. So it's for human readable data, so to
So
speak.
you could build some really cool visualizations off of it that were approximate. You could build visualizations off of it that were approximate.
But I can get this to very exact values. As long as no one is trying to hack it, the values are very close to the truth. And so I can get it with as many exact as you do. But for instance, I count number of nodes online within plus minus 2% of the truth. But that's 1,001.02 million.
Yeah.
Did I respond to your question?
I didn't ask you a question. I was suggesting something.
Question
about
utility.
Yeah.
Users over, for instance, in the night at 4 o'clock. Usually there's not many users, and then that afternoon, I can do all that. Yeah. Of course. And actually, we have ways to do that for each node. So you can click on your statistics window and get statistics for part of the day when you weren't yourself online. And I'll teach you how to do that. I call that cloning, and I'll tell you about cloning. I don't know why no one else came up with cloning, because it's so simple. You can actually, when we connect to the network, we simply, many of these elements, they only work when you're already connected. You need to know lots of data to behave correctly. But to solve that, I simply connect one node and copy all this data. So I'm bootstrapping by just giving me all the values to run your algorithms. And then I start. Yeah, I see. Yeah. And you can do, of course, with all these statistics. So I can get all the old statistics from you, and then immediately we can feed these curves. So that's part of how I could calculate the number of nodes per month, because you don't need to know that all the time to count that. You just want to keep on doing the work. So you inherit the work from another and keep on helping out, and when you leave, hopefully you hand it over to someone else. Yeah.
Will you go through the cloning later?
Yeah. Actually, I probably will mention it as part of different values, because of some of them need start values, and then we do cloning, so I'll show you too. Or remind me if I forget. Let's see what more to say about this. Yeah, so these are mostly for human pleasure, unfortunately.
It also impacts on the perceived quality of the network. So a malicious attacker wanting to undermine the perception of quality of the network could try and mess with these values.
Yeah, of course. You could, for instance, make the number of nodes online would be ridiculous. Make it 4 billion nodes, and then everyone knows it's obviously false.
Yeah.
So that would be unfortunate, but there's nothing we can do about that. We could, of course, use all 3 methods to measure it, and then we can see if it's obviously wrong, because the methods are differently secure and will react differently to the attacks. You can see when the values goes apart, and then you know you're under attack. I think that would be a waste of code. And we could just write a disclaimer. These are just statistical values, and we know they are not secure, so don't trust them.
Is it possible to come up with some sort of way to, say, leverage, I don't know, public key infrastructure or something so that a node can be identified as legitimate somehow?
Actually, they need a single trusted
Maybe
source.
you could have like a proof of work thing, so it's not like viable to the resources to lie would be too expensive.
Right. So each node could pass along to the next trusted node this thing, and you become vetted, essentially, something like that. So that way you wouldn't need a central authority.
Like,
Actually, we
people
have ways to
you
have
give
that.
top
You're
proof
talking about
things
trust
that are
systems,
corroborated.
basically.
Well, because to avoid number of nodes online being like faked, or
The problem here is you can't know because the node claiming to have seen lots of nodes, in a way, you can't know if it's true. It might have a node that he sees that you don't see, because you can't edit that part of the network. So it's, for these ones, it's very hard to have good trust. For instance, a node can behave well in all other manners. You think this is a good node because everything it does is correct, but it just lies about one of these values. How will you know that he's behaving well by lying about one little thing?
But perhaps the other nodes that you know have different.
oh yeah. So you never ask one node. You have to ask several nodes
Yeah.
for consensus.
Yeah, that's what I'm doing. But still, when I go through these elements, you will realize how you can hack it. I'm so sorry. So we'll do that when we do it. If you don't realize it, I will show you how to do it. But I think you guys will start to, I can hack this like this, and I can crash it like this. So I'm sorry. No one has come up with any secure way of collecting statistics. They have, when you were talking about, we can try to figure out which nodes are evil and which ones are good and stop talking with the evil ones. But that's a hard problem because if one node claims to discover this one is evil, it has to tell its friends about that. So node can be, you can insert like 100 nodes that behave really well, and they in turn insert friends. They can start lying about other nodes and say that's evil, that's evil, that's evil. But as long as they behave well themselves, you think they are telling the truth. So you will stop talking or refuse to connect to nodes that actually aren't evil. Or the other way around. You could, these 100 good nodes, fake good nodes, can bring in 100 other friends and claim they're good, despite they're doing bad stuff. And the nodes telling you that the other ones are good. From what you see, because you're already talking about them, they are behaving well, so you trust them. So trust is actually a very hard problem. But for some applications, we have working trust, and we'll hopefully spend half an hour on that if we have time. Because if we do, like for instance, mailing list or web forums where you write comments, you have to have some way to get rid of the users that are only spam or sabotage, then use trust systems to figure out who's good and bad. And that seems to have a method that works. That's actually also fully distributed, not centralized in any way. But we'll get to that. But that's, and last time I checked at least, for most of the problems we have no good way to do that. So I stick to trying to make my stuff so robust that you have to have thousands of nodes to do it. You can't do it with 1 or 10 or 100 nodes. And that's all I can do, make it too expensive. But these ones, unfortunately, there's no way to make it too expensive. I can, with one node, sum it up all to deal with statistics, almost. Okay. Most people, at least in the early days, they thought that peer-to-peer net. Should we have a break now?
I'm thinking we should maybe break close to 1 o'clock.
Yep, that's
So
good.
about 15 minutes.
Sorry?
About 10-15 minutes time. Is that okay?
Yeah, that's good.
We can walk down somewhere and get some lunch and come back.
We can break between any two slides, or in the middle of a slide, that's okay. By the way, we're supposed to have a break once an hour
Yes.
to stretch our legs, because I know I can be a bit more monotonous. We can't pronounce that word. So just remind me when it's time. If you see people getting unruly or something, because I tend to forget.
The talk is awesome so far.
Yeah,
Loving it. Yeah, really good.
Thanks. Okay. So yeah, so just remind me. I don't crash when I get interrupted, not that much at least. So yeah, this is one thing I love. It seems I've always invented it. I don't know if I was the first one talking about this, but back in the old days when people were building peer-to-peer networks, they just had one layer. They had one big swarm. Everyone was connected in one brand network, and they tried to do everything immediately on that one. So for instance, if it was a chat system, the chat room consisted of a number of nodes spread out, and they were routing messages over the big network. So if there were 1 million nodes and 10 nodes in chat room, the message was spreading out over the network and loading all the other nodes. And that's really stupid. Of course, if you have a chat room, the 10 nodes in that chat room, they should create their own little random network. They connect in a swarm and broadcast messages within that room. But they of course also stay in the big mothernet and so take part of the network, so you can find them and so they can find other
General
networks.
services, just
Yeah.
another net, specific services for your own.
Yeah. So
That's not true.
yeah. Yeah. So each node is taking